Hello, Mario 2019 Engineering Maths Weekly Quiz 9 Review. Hello, welcome. Today's background is an iconic scene from around Hamilton. I've been here many times with my children and wife at different times to enjoy this lovely spot. So if you can tell me where it is, you're the first person to record your result in the comments below the video, you get one free spin on the Wintech vending machines at the Rotokauri Hub. So watch the video, have a look at the review, the quiz review, and yeah, you could be a winner. You could be a winner in many ways. You could be a winner in that you have got a very good test result, or that you didn't get a good test result, but you've managed to review it and you know how to get a good test result next time. So good luck with that, and well, we'll see you again at the end of the review. Over to the big screen, and here we go. We've got all ready here, and over to the Wacom tablet and see if we can get something going here. So when we take a look at this one, we will see that it's there like so. We have to decide which one are we going to which method are we going to use. We could just differentiate it straight away, but we can't do that. We can see it's quite complicated. So are we going to use the chain rule, the product rule, I'll just call that the pro, or the quotient rule? There's three rules that are recorded on our. Okay, so straight away we can see here that this one here is not a quotient. It's not one of those. It's not a product. So this one's got to be the chain rule. And the chain rule says that dy by dx equals dy by du times du by dx. Okay, so we know what y is there. So what's and we're going to make u equal this little bit here, 7x plus 4. And therefore y now equals u to the power of 5. Okay, so now we can say, right, du by dx equals 7. Just differentiating that, 4 becomes, so that's 7. And then we can say dy by du equals 5 u to the power of 4. So that's, we've got those. Now putting those together, dy by du is, so dy by dx, which is what we're trying to find out, dy by dx. The differentiation of y with respect to x, which is the slope of the graph on any point of the graph at x, the slope, equals dy by du, which is 5u to the fourth, times, and we just put a little dot for the times 7. So working on that, we can now say 7 times 5 is 35. Let's put u back there, which is 7x plus 4. And then that's to the power of 4. That's my answer. 2 marks. Okay. All right, so in this case here, I used the chain rule. Okay. All right, moving right along to question 2. I'll just move that down there, put it up above my head so my head doesn't get in the way. Moving along to question 2. Looking at this here, we can see, well, we've got a log and then we've got the sign inside it. So once again, I think we're going to have to use the chain rule here. Decisions. We'll just position that with the mouse. And I think that tells it. I think we're going to have to use the chain rule here. Chain rule. That's the one we're going to use. I'll just circle that. Chain rule. And that is just from your formula sheet, dy by dx equals dy by du times du by dx. All right, so there we are, we've got y. So let's say u equals sine x. So now y equals log to the base e of u. Okay, so du by dx equals du by dx equals cos x, just from our formula sheets. Okay, and dy by du of log to the base u equals 1 over u. Ooh. So putting them together, dy by dx equals dy by du, 1 over u times cos x. Now that equals, putting back in new, cos x. We could put brackets around the x, just to keep everything nice and consistent. Cos x over sin x. And if we look up our formula sheet, you'll see that that equals cotangent x. Cotangent, which is 1 over the tangent. Cotangent x. Cotangent x. There you go, 2 marks. Job's a good one. Okay, now on to number 3. And what have we got here? Right, well, this looks very much like the product rule. Oh dear, that's going to be. So this is the product rule. And this says f dash of x. Let's use a different terminology here. Equals f dash. Oh no, let's back that truck up. Oops, didn't want to do that. I'll go back to my mouse. Okay, right. So, I hit the wrong button there. Okay, here's our product here. Product rule. So what we can say there is dy by dx equals f dash x, which is the differentiation of the first function times the second function, plus g differentiation of the second function times the first function. So in this case here, we've got so when the product rule is, we've got two functions from order, we've got f of x equals 2 to the power of x. Okay. And f dashed x, differentiation of f of x, equals e to the power of x. Oh, e to the power of 2x. Yes. Equals. Oh, no, it doesn't. Okay. So, yes, I've just overlooked a little bit. Oh. Oh, I've done that again now. Okay, f dashed x. Now, f dashed x of f of x, as you can see, f of x is e to the power of 2x. which needs the chain rule to differentiate it. So f dash x is going to equal, if we do that over here, let u equal 2x. Okay, u equals 2x. F of x equals e to the 2x. U equal, no, drop that back again. F of x now equals e to the u. Du by dx equals 2. Right? And dy by du, I'm making that there equals e to the u. Okay, therefore f dashed x equals du by dy by du, or I'll just put it as 2 e to the u, which equals 2 e to the 2x. Okay. And so that's the product. The product will there. In here we're going to have to use the chain rule. Okay. Now over here let's do g of x, the second function, equals cos 3x. And again, we're going to have to use the chain rule again to differentiate that. So we've got to use the product rule to differentiate the function, and then each of the functions require the chain rule to differentiate those. So let's just say, and we're going to let u equals 3x du by dx equals 3. Now y equals cos u in the adjusted chain rule, and dy by dx, dy by du, sorry, equals minus sine u. So g dash of x, which is what we're trying to find here, equals 3 negative, I'm going to put the negative 3 sine u, which equals negative 3 sine 3x. Okay, so that's the two product rules. So now we're going to go dy by dx dy by dx now equals f dashed x, which is 2e to the 2x times g of x, which is cos 3x plus g dash of x, just down here, negative 3 sine 3x I'm just going to go back. I don't want that bracket. Negative 3 sine 3x so that's g dash of x times f of x, which is e to the 2x. Now that would be a pretty good accomplishment to just get there, but I can see there that we could factorize that just to make it a little bit simpler. E to the 2x, as you can see, is common there and there. And so we'll put that in a bracket, and then we'd get 2 cos 3x minus 3 sine. Oh, I keep doing that, don't I? I don't really want to. Minus 3 sine 3x. Okay, and that is the answer. E to the negative 2x bracket 2 cos 3x minus 3 sine 3x. 2 marks. So very important that you write down what equals what, because it's quite often you'll write y equals 2 to the blah blah blah, and then you'll write equals when in fact you mean the differential equals. So It's just really a matter of keeping track of things. The actual differentiation of the individual items at the basic level is relatively simple, and all of the rules are written down on the sheet for you. So that's questions 1 to 3. So we'll turn off layer 1 and turn on layer 2. Come in layer 2. Okay, and apparently that's invisible, but now it's not. We'll just go up to the top here. Okay. Find the coordinates and nature of all of the turning points of y equals x squared plus 10x plus 26. So look, it's pretty obvious for these types of things that you're going to have to differentiate it. So let's just okay, differentiate it. So dy by dx, which is the differential, dy by dx equals 2x plus 10. Now, just little things going on in my head at the moment. That's an x squared graph. So, well, you know, you haven't come 10 weeks into this maths course, you should know that that, of course, is a parabola. I mean, we learnt that. I mean, we don't need to know that for this question, but it certainly helps. Parabola. And that's a, that parabola there is positive x, so it's going to do something like that. It's going to be that shape. So straight away I know that it's a minimum, and I also know that because of the shape it's in, that's the y-axis there, 26. All right, and I don't know where the I know that that's 26. I can draw the y-axis in, because it goes through 26 like that, and then that's going to keep going up. Oh, I don't want to do that one. I wanted that to be in green. So that's going to keep going up there like that. So that's 26 there. And what I know is that dy by dx is the slope of the graph at any point given by the formula. So I know that, I'll get back to red. I know that when dy by dx equals 0, that I must have a turning point. TP, turning point. Okay, so therefore 0 equals 2x plus 10. So if I subtract 10 from each side, okay, I get negative 10 equals 2x. 2x? I don't want to work out what 2x is. I want to know what 1x is. So I'll divide by 2. I can just put a line under there. Divide by 2. All right, and I'm just going to flip them around side for side. So I've got 2. Oh, no, I haven't. I've got x. X x equals -5. Okay, and so let's have a look here. When x equals -5, because remember I need to find the coordinates. Okay, so when x equals -5, that's going to be the turning point. So I know that this turning point here, that's going to be x equals -5. So I can draw my x-axis in here. And I can sort of say that that point there is going to be -5. Okay, that's that point. But when x equals -5, what's my y? Where on the graph is my y? Well, that's when x equals -5. So that's where I've got to go up to here, because this tells me the graph. So when x equals -5, oops, I want a different color. When x equals -5, y equals -5 squared plus 10 times -5 plus 26. Okay, so -5 squared, well, you could put that on the calculator if you wanted to, but you're clever, so you should be able to do it in your head. -5 squared is 25. And 10 times -5, well, when you multiply them by 10, you just add a 0, so that's -50. -25, oh, sorry, 25 minus 50 is -25, plus 26 is 1. Oh, that was easy. But you could do it on the calculator. You've got the calculator there to do it. So that means that that point there is 1. So the coordinates, and remember we need coordinates of the TP equals x is -5 and 1. Ooh, this might have been quite handy when we were doing parabolas, you know. This could have been very handy when we were doing parabolas. Now we know this information. When we do parabolas, well, we could use it maybe. All right, so now we've got the turning point. Is it a maximum or a minimum? Well, because we did parabolas, we know that it must be a minimum, but we've got to prove it. So we know that, well, we look at, to determine the nature of it, we look at the second derivative, d2y by dx, and that equals, we just differentiate it again, and that equals 2. It's positive. Okay, it's positive. therefore it's increasing, it's getting bigger, therefore it's a minimum. Okay, because we're here and it's getting bigger. The tangent, it's getting bigger, so it must be, therefore, TP, oops, oh, that's an abomination there. Let's just get rid of that. Oh, one too many. TP is a minimum. Okay, so we have a minimum at -5.1. And we know because we drew the parabola. So moving right along, let's go to this one here, and question 5. Okay, so we're going to have to be quite good with the displacement in meters of a salmon from a particular location is given by this formula here, where t is in seconds. Find an expression for the salmon's velocity. Well, we know that velocity equals ds by dt. The increase in distance over time, that's velocity, measured in meters per second. So we need to just find an expression for that. So we're going to go 3t squared over 30 minus 0.06 t, 2 times 0.3, take it down, minus 0.41, which can be written as 3 over 30, which is t squared over 10 minus 0.06 t minus 0.41. How fast is the salmon going after 2 seconds? Okay, so and we could write t squared over 10 as 0.1. So let's, how fast is the salmon going after 2 seconds? Well, let's see. That's the function for the velocity. So V2, I'll just do it like that. It's another way of writing it, just gives us a bit of room, equals 0.1 times 2 squared minus 0.06 t, oh, oops, times 2, .06 times 2 minus 0.41. So let's not get too clever with that. Let's bring in the calculator, because the calculator enables us to do checks on things. So 0.1 times 2 squared, okay, 0.1 minus 0.06 times 2 minus 0.41. Enter. Negative 13 over 100, and we'll convert that to a decimal. Minus 0.13 minus 0.13 meters per second equals minus 0.13 meters per second. All right, let's put the calculator away for a little while. So when is the salmon at rest? Okay, well, the salmon is at rest when its velocity equals 0. So I'll just do C up here. So the salmon is at rest when V equals 0. V equals 0. The salmon's at rest. Okay, so velocity. So we get 0 equals 0.1 t squared. 1 over 10, 0.1 t squared, minus 0.06 t minus 0.41. And we should recognize that that's a quadratic equation, and we are able to solve that using the quadratic equation. Minus b, or it's x equals, and we would expect there to be two solutions, minus b plus or minus the square root b squared minus 4ac all over 2a. Now in this case here, a equals 0.1. B equals 0.06, negative, and C equals negative 0.41. Okay, so let's get our calculator out, and well, we'll put it, where will we put it? Oh, over here. That'll do. Oh no, my head's in the way. There we go, let's put it there. So now we have to get this all set up. Alright, so we'll do the positive one first. Negative b Oh, it's over something, so it's all over, isn't it? It's all over. It's all over 2a. Okay, negative b, and b is negative 0.06, so we'll just 0.06. Okay, and we'll do the positive one first, and then we'll come back and change. Plus, no, I need to do that bit first. Okay, well, yep. So, negative b, which, we're going to do that bit, 0.06. Okay, that's the negative b, and then we'll do plus the square root of b squared, which is negative 0.06 x squared. I don't know why I put the bracket there. We'll come back and take the bracket out. Okay. And then we'll try and come to the end here. Drop down. Minus 4 times a, which is 0.1. 0.1. 0.1 times c, which is negative 0.41. Negative 0.41. Okay. Yep, that'll do. Ooh. Hang on, I'll just go minus 0.6 all squared minus 4 minus 0.41. Seem to. Yeah, all over 2a, 2 times 0.1. Okay, now it would pay to check that, I think. So let's just have a look. Minus 0.6, but because the b is minus. Anyway, that'll become positive. So we've done that little bit in the head here, and then plus the square root of minus 0.6 squared. We could have left the minus out because the square would have made it positive anyway. Minus 4 times 0.1 times minus 0.41 all over 2 times 0.1. Let's push the equals. And we get that there, which is 2.302. Now that does not quite seem exactly like what I was expecting. So I'm just going to check some other notes that I made here. And let's see. Yes. Four times. Okay, I seem to have. I can't see where I've gone wrong here. Okay, but 0. Minus b. Well, I'll put it in properly. Minus, and then we'll put a minus in there, which shouldn't make any difference. Minus plus the square root of 0 minus negative 0. Oh, now that could be a bit of a problem. It shouldn't be a problem, but I will put a bracket there just to make sure that yep, okay, it's better. Minus 4 times 0.1 minus times C minus 0.41. Yeah, which would seem to be correct. Okay, just checking some other bits of papers here. Okay, let's see what we got here. Equals. That's the answer I was expecting. So it just might have been something in the calculation there. It might have been that negative was sort of hanging out somehow and not included in that number. So that gives us that there, which, so we can come down here and say x equals, well, in this case, no, it's, yeah, I'll cross that out of there, actually. It should be v. The velocity. No, it's the, what is that? Hang on. Oh, that's t that we're calculating there. Yeah. So this here should be t at rest when v equals 0. Yeah, the velocity equals 0. This is t. T. That's right, not x. And this here will be t as well. So it's very important that you t equals, okay, 2.347 seconds. So that's one. Now the other one is when it equals the negative value. So let's, so what we do there is we just, on the calculator, we've got this all set up. So we don't have to recalculate it. And we just go back minus there, and then we calculate that out. Oops, if we can. Okay. Equals, and then we minus 1.747 minus 1.747 seconds. Okay, now that one there's not going to be an option because it's a negative thing, so it's before our calculation, you'll see, because the formula only works between when between 0 and 10. So that's the range it's given here, so that we can reject that one. I'll just so we can reject it because it's not a viable option. So t equals 2.347. that's when the salmon is at rest. When is the salmon at rest? T equals 2.347 seconds. Okay. That's when that is. Now, find an expression for the acceleration of this salmon. I think we can, well, we'll put the calculator up there just in case. And we'll just, we can't drop this down too much. But expression for the acceleration, acceleration equals dv by dt. V is the velocity, so we just differentiate the velocity with respect to time, and in this case here it's equal to, our velocity is 0.1 there, so it's going to be 0.2 t. I've got some notes here. 0.2 t. Just finding my notes. Just to make sure I get it right. 0.2 t. Yeah. And minus 0.6. That's it there. Acceleration is 0.2 t minus 0.6. I'll just also put that, if you kept the fraction, 0.2 t just is t over 5. Minus 0.6. Okay, so 2 marks for all of that. Ooh. Okay, alrighty. So let's head back to the talking head. So there you go. We have worked our way through a quiz 9, the penultimate quiz. One more quiz to go. I would say, in terms of, the actual thinking and what have you, it's more about process, and the actual, the differentiation side of these is actually not that difficult. It's more the process and the understanding why you have to do it. That acceleration, oh yes, that would be the expression for that. Acceleration would be in meters per second squared. So there we go, we complete it. So well, I hope that's been helpful for you. If you still have any questions, you could always make a comment below the video. Don't forget that if you're the first person to name this iconic place in Hamilton here, in the comments below the video on the YouTube you will be you could be the winner of a free spin of the vending machines at the Wintec campus. So, thanks very much. All good. Enjoy your maths, and, well, we'll see you again in the future sometime. Cheers. See you.